Welcome to Natural Habitat Adventures Daily Dose of Nature. Today's presentation, Alaska's Melting Glaciers and the Race Against Time, is brought to you by NatHab Expedition Leader, Laura Geissinger. Now, Laura earned a degree in biology and environmental education from Messiah College and has extensive experience teaching outdoor education, serving as a camp program director and hiking guide, and developed outdoor education programs internationally, including in India. She led expeditions for middle and high school students teaching backpacking, canoeing, caving, and climbing, and has studied abroad in England and Africa while traveling to destinations including Belize, New Zealand, Australia, and Antarctica. Now based in Alaska, where she was born, Laura guides wildlife adventures for NatHab, sharing her knowledge on the state's plants, animals, and natural and cultural history. Laura, thank you so much for being here today. The show is yours. Take it away.
Thank you, Robert, and thank you all for joining me today. The glaciers of Alaska connect local life to global climate patterns, shaping ecosystems, sustaining communities, and reminding us that protecting them means protecting our shared future. When people think of Alaska, glaciers often come to mind. If you have ever visited, you have probably seen some of our amazing glaciers. It is estimated that there are over 100,000 glaciers in Alaska, covering about 5% of the state. Ice covers roughly 10% of the world. Glaciers sustain life. They replenish ecosystems and provide fresh water to humans and wildlife. Their slow movement across the land leaves an impressive signature on the planet, sculpting mountains and valleys that draw people to the magnificent landscapes they leave behind. There are numerous popular glaciers people visit when they come to Alaska. Hubbard Glacier, which we are seeing here, is Alaska's largest glacier, or largest tidewater glacier, I apologize, and is seen by many people on the Inside Passage cruises. The Mendenhall Glacier is a highway accessible glacier outside of Juneau with year-round access. So it's also a common glacier people on the Inside Passage cruises see. It flows from the Juneau ice field and is known for its dramatic visual impact. The area is also subject to glacial lake outburst floods, which can and have damaged nearby homes and have caused significant flooding. And in more recent years, these outburst floods are occurring more frequently. The Matanuska Glacier is the largest glacier accessible by car in the United States. It is a couple hours north of Anchorage, and it is a valley glacier that is 27 miles long by 4 miles wide at its base. It's visible from the Glen Highway, which is one of the major highways in Alaska. Exit Glacier is one of the most accessible glaciers in Alaska. It's located in Kenai Fjords National Park near Seward, and it is on the only road into Kenai Fjords National Park. I have watched Exit Glacier change significantly in my lifetime, and there are hiking trails that allow visitors to view the glacier and the effects of climate change, which is evidenced by year markers showing significant glacial retreat. So in this photo, where it says 2005, that is where the ice was in 2005. And this photo was taken in about 2019. Along with the markers that are at Exit Glacier showing the retreat of the glacier, it is also a well-mapped glacier where people can see the mapping in the visitor center and on some of the signposts that show you how the glacier has retreated over the years. And so if you look where that white line was at 1950, and you can see over the years the changes that have occurred in that glacier. Another popular glacier is Ruth Glacier in Denali National Park. And this is a glacier that many people will land on when they're doing flight seeing trips around Denali. And the upper reaches are approximately 3 vertical miles below the summit of Denali. And the Ruth Glacier is a very active glacier, and it moves at a rate of about 3 feet per day during the summer. So I've just shown you some very popular glaciers in Alaska, but what actually is a glacier? Well, a glacier is a large perennial accumulation of ice, snow, rock, and sediment that forms on land and moves slowly downhill under its own weight with the force of gravity. They form from compressed snow that recrystallizes into ice over decades or centuries, and they are a significant source of Earth's fresh water. I like to think of glaciers as rivers of ice that continually flow downhill, driven by their own enormous weight and gravity. They are created by time and pressure. A glacier begins to flow when a thick mass of ice begins to deform plastically under its own weight. Thick glacial ice is quite heavy, and the great weight of the glacier may cause the ice along the base of the glacier to melt. So that friction is causing some melting underneath the glacier. Melting occurs because the temperature at which ice melts is reduced due to the pressure exerted by the weight of the overlying glacial ice. Heat from Earth's surface may also cause ice to melt along the base of the glacier. The process of basal sliding occurs when a thin layer of meltwater accumulates between the basal ice, or the ice at the bottom of the glacier, and the Earth's surface. The meltwater functions as a lubricant, allowing the glacier to slide more readily over the bedrock and sediment underneath it. As they move, glaciers act like giant plows, shaping the earth beneath it by scraping and carving the land and creating new landscapes. So let's look a bit more closely at the formation of the glacier. You have several different zones on the glacier, and your most upper zone is the zone of accumulation. The zone of accumulation is where glacial ice is being formed. In this zone, there's more snow is accumulating each winter than what is melting away during the summer. Buried accumulations of snow turn into firn and eventually recrystallize into glacial ice. Firn is granular snow that has not yet been compressed into ice. So it's this intermediary stage between fresh snow and glacial ice. The firn line, or snow line, as it's called, is the distinct boundary visible on a glacier at the end of the summer melt season, separating the zone of accumulation from the zone of ablation. Generally, the zone of accumulation is clean and icy and looks fresh, and the zone of ablation is dirty and covered in sediment and looks somewhat like a gravel pile by the end of the summer. That firn line marks the lowest elevation where firn has survived the summer melts. Above this line is the accumulation zone, and below it's the ablation zone. Since it is a visible line on the glacier surface, its position changes throughout the summer, as snow melts and retreats uphill. So earlier in the summer, that firn line is going to be much lower down in elevation than it is later in the season. And then you have your zone of wastage or zone of ablation. And this is the area of a glacier that experiences a greater amount of melting than glacial ice formation. In this zone, as the ice melts away, bits of sand and gravel on the surface of the glacier are left behind. This zone is always being replenished as glacial ice continues to flow downhill from the zone of accumulation. So there's always more snow and ice being added to this zone. In a glacier, the accumulation zone is where the snow and ice are gained through precipitation, such as snowfall. The accumulation exceeds any loss from melting, evaporation, or other forms of ablation. This net gain in mass causes the glacier to grow, with the process of snow compressing into firn and then into ice occurring here. Snowflakes become denser, transforming into firn, which, like I mentioned, is that transitional stage between snow and ice, and then into solid ice. So if you look at this diagram, snow is about 90% air, and as it gets compressed, it becomes coarse-grained snow, and it's about 50% air. And as that compression and recrystallization happens and it becomes firn, it goes into 20 to 30% air. And then down towards the bottom, as it gets compressed into glacial ice, you have less than 20% of air in your ice. In a glacier's ablation zone, there is a net loss of ice mass due to melting, sublimation, where ice turns directly into water vapor, and calving, which we see in this photo here. And that's where icebergs or chunks of ice are breaking off into the water. And the ablation zone is a lower altitude region of the glacier. And this part of the glacier experiences warmer temperatures than the zone of accumulation does because it is lower down in altitude. And so there are higher ablation rates down at the in the ablation zone than up in the accumulation zone. And this temperature difference is causing the glacier's overall size and length to decrease if the loss in the ablation zone exceeds the gain in mass in the accumulation zone. So why does all of this matter? Why do glaciers matter? Glaciers play an irreplaceable role in our natural world. Glaciers are the largest freshwater reserves on the planet. The Earth is roughly 71% water. Of all of the water on Earth, less than 3% of it is freshwater. Of that, glaciers and other ice stores about 70% of Earth's freshwater. Water in glaciers may seem really inaccessible compared to what is found in lakes and rivers, but glacial melting during dry summer seasons supply nearly 2 billion people with water worldwide. Glaciers and sea ice are also important components of the Earth's thermostat. Glaciers help keep solar radiation out because of the ice albedo effect. Glaciers regulate climate by reflecting solar energy back into space through their white, icy surfaces, which keeps the planet cool. The bright white surfaces of glaciers, ice sheets, and sea ice have high albedo meaning they reflect a large amount of the sun's energy back into space. This reflection prevents the Earth's surface from absorbing excessive heat, which helps to maintain a cooler, more stable climate. Glaciers also influence global temperatures by affecting ocean circulation. As glaciers melt, they release vast amounts of cold, fresh water into the oceans. Too much melting can affect the density and salinity of ocean water, potentially slowing down large-scale ocean currents. Slowing ocean currents, in turn, can impact regional and global climate patterns. Glaciers also regulate sea levels by holding large volumes of fresh water on land. Their melting into the ocean adds water, causing sea levels to rise, while their presence on land acts as a reservoir that removes water from the global ocean system. A significant global rise in sea level is directly linked to the melting of glaciers and large ice sheets in places like Greenland and Antarctica. Glaciers are also very important because they maintain and create unique habitats by acting as natural water reservoirs, regulating water temperature, delivering nutrients to downstream ecosystems, and creating distinct landforms. Gradual glacier melt delivers nutrients to lakes, rivers, and oceans, sustaining habitats for plants and animals. Those nutrients can drive blooms of phytoplankton, the base of aquatic and marine food chains. Glaciers often have an indirect impact on wildlife and fisheries. The cold water that comes off the glaciers in the summer also helps to regulate the temperature of alpine stream habitats, which is important for sensitive aquatic species. In some regions, glaciers provide life-sustaining water for people as well as wildlife. This is especially true when the snowmelt has declined over the summer season and glacial output increases. During dry periods and heat waves, glaciers can supply even more meltwater, helping to maintain river flows and support local biodiversity. As noted, glaciers play an important part in our world. People and plankton reap the benefits of seasonal glacial melting, but there is a limit to how much melting is too much. Glaciers are a useful indicator of climate change. Glaciers have cycled naturally through periods of advance and retreat for hundreds of thousands of years. But evidence shows that glacial melting is happening at an unprecedented rate due to anthropogenic causes. Starting in the 18th century, scientists began to study glacial fluctuations. With very few exceptions, most of the glaciers on Earth are shrinking. A study published in 2014 showed that starting in the late 1970s, glaciers crossed an invisible line into a declining state that cannot easily be attributed to natural causes. The study relied on multiple global climate models to simulate the mass balance of glaciers worldwide, excluding Antarctica. The authors concluded that from 1851 to 2010, only about 25% of the glacier mass loss could be attributed to human-caused climate change. However, from 1991 to 2010, the glacier mass loss increased to about 69%, suggesting with high confidence a strong signal for human-caused climate change. Now I'm going to show you some repeat photography from glaciers across Alaska. This first picture is a picture of Northwestern Glacier in Harris Bay, Kenai Fjords National Park in 1909. At this point in time, the terminus of the glacier was taller than 164 feet. And in this image, you can see that there was not visible vegetation. "95 years later, in August 2004, the glacier had retreated out of view. The terminus in 2004 was located 6.2 miles to the northwest of its terminus 95 years before. In this next photo, this is Pedersen Glacier. This is also in Kenai Fjords National Park. It is in Ayalik Bay. And this photo was taken from the shore in Ayalik Bay. And it was taken in July 1909. The north side of the glacier can be seen where it's grounded above the tidewater with little to no vegetation. And you can see where the face of that glacier is very prominent, and you can see where that activity of the glacier is happening. This photo was again taken 95 years later in August of 2004. The glacier had receded 0.93 miles, revealing a field of diverse vegetation, including alder and spruce. This is an area that I spend a lot of time in, and since 2004, this glacier has receded even more and can barely be seen from this point on the beach. This is Holgate Glacier, and if you go on our Ultimate Alaska adventure, you will probably get to see this glacier. This photo was taken near the head of Holgate Arm in Kenai Fjords National Park in July of 1909. And on the left-hand side, you can see a second glacier, which they called Little Holgate, and those connected behind the rock in the center. And you can see that Little Holgate terminates at the shoreline, and there's not very much vegetation in this photo. But really, look where you have the rock in the center dividing the two parts of the glacier, because in this next photo, 95 years later, in August 2004, you can see that both glaciers have receded considerably. Little Holgate was now separated into several smaller ice masses. You can see there on the left-hand side that it's no longer a continuous flow of ice. And Holgate's terminus retreated from view, where before you could see it come the whole way down to the water. Now it's out of view, and you can see that there's vegetation growing on the hillside around the glacier. This is Ayalik Glacier, also in Kenai Fjords National Park. This photo was taken off the shoreline of Squab Island in 1909. And at that point, it was an active calving glacier, and the terminus was as tall as 131 feet high. But there was not much vegetation. If you look at our next photo, taken 96 years later in August of 2005, the glacier has thinned roughly 70 to 160 feet and retreated just under 1,000 feet, but it remained fairly close to its 1909 position. Ayalik Glacier is still a major tidewater calving glacier, but vegetation has developed on most of the exposed land surfaces around it. Ayalik Glacier is a really good example of a glacier that the face of it has remained fairly close to its position, but the mass of it has thinned significantly. So when we think of glacial retreat, we usually think of it moving backwards, but it doesn't always mean that. It can mean narrowing and thinning as well. This is Bear Glacier, which is also a common glacier we can see on the Ultimate Alaska Adventure. And this is in Kenai Fjords National Park as part of the Kenai Mountains. And this first photo was taken in September of 2002. You can see that the glacier is retreating, and you can see that the terminus of it has calving. There's lots of ice chunks there in the water. Before 1950, the basin here at Bear Lake was filled with the glacier. And so there wasn't this calving action prior to 1950 because it was just that lake there was full of the actual glacier itself. And then between 1984 and 2002 was when the lake really started to form. And by 2002, it had quadrupled in size. And then over the next few years, the terminus receded 1.9 miles. So this here was in 2007, and you can see how much the face of Bear Glacier has changed in those few years, in those 5 years. So this is Muir Inlet in Glacier Bay National Park in 1880. You can see that we can't see any big mountains in the background. You can kind of see a little rock over a piece of the ice, but you can't see any mountains. It's mostly just an icy landscape that you're seeing. In 2003, a photo was taken at the same location, and now you can see the mountains. There is no ice in the way, and you can only very distantly see a glacier way off in the distance. This next picture is also in Glacier Bay National Park, and this one was in 1906, and this was Carroll Glacier. And you can very prominently see the glacier there in the foreground. It's very little vegetation, even though there's rocks there in the foreground. Vegetation hasn't started growing in that area. It hasn't started growing on the hillsides next to the glacier, and that means the glacier had been there more recently. But by 2003, you can only see a tiny sliver of the glacier off to the left-hand side. You can see a few remnants of ice in the water, and you can see that on the hillsides of either side of where the glacier was is now covered in alders, and the foreground has been overtaken by vegetation. This here is Plateau Glacier in Glacier Bay National Park in 1961. You can see how the glacier comes down out of the mountains, comes the whole way to the water. And if you look very closely in the center of the photo, you can actually see some people out on that rocky point. In 2003, this was the same view. You can see that there is just remnants of the glacier left higher up in the mountains. It no longer cascades down to the water line and does not fill the valley in front of it. This here is Reed Glacier in Glacier Bay National Park in 1899. This area is covered in ice. You can see where the water meets the ice and where it's a tidewater glacier. There's not vegetation in the foreground. You are predominantly seeing the ice of the glacier with some rocky slopes exposed. In 2003, you can't even see the glacier except for the tiniest sliver on the left-hand side of the photo. The ice is gone. There are some remnant chunks coming from the glacier floating in the water in front of us, but it is now covered in vegetation. The hillsides are covered, and you can see that little outcropping of moraine, the gravel into the water. At one point, that was where the terminus of the glacier was, where it was acting as the bulldozer and left that gravel behind. This was Muir Glacier in 1892 in Glacier Bay National Park. And this used to be one of the highlight attractions of Glacier Bay. And it filled the entire east arm of the bay. In 2005, Muir Glacier is grounded and no longer touches the sea. And you can barely see it back up in there in the mountains. It is no longer the draw that it was for people coming to Glacier Bay National Park. This is a different vantage point of Muir Glacier in 1941. And you can see how this is just filling the entire valley and coming and down to the fjords and meeting the water. In 1950, the glacier had retreated to where you can see in this image now. I'll show you that again. In the course of 9 years, the glacier went from filling that entire bay to touching the water still, but not encompassing very much of the same landscape it had previously. This photo is of Portage Glacier in 1914. Portage Glacier once was very visible from the roads in Alaska. Now you have to take a boat or hike out to it. And this photo was from the same spot 93 years later. You can barely see the glacier. It's tucked right there around the corner of the mountain, and you can just see the tail end of it. And today, that glacier has retreated even further back behind those mountains. And lastly, these are repeat photos of Mendenhall Glacier. And these were taken in 1893 and 2018. Suicide Basin was formed in the early 2000s when Suicide Glacier detached from Mendenhall Glacier. And now annual outburst floods originate from Suicide Basin, which contain remnant ice from Suicide Glacier. So you can see how in the 1893 photo was all one glacier. And by 2018, it was now 2 distinct glaciers. As you can see, glaciers across Alaska have receded significantly. The production of greenhouse gases, such as carbon dioxide and methane, is contributing to a slow increase in global temperatures worldwide. According to NASA, glacial ice is now melting at higher rates than ever before. Small valley glaciers are the most vulnerable glaciers. There are many valley glaciers in Alaska, but not many of them are monitored. In Glacier National Park, where they are monitored, scientists have seen a significant decline in their numbers. In 1910, there were about 150 valley glaciers, and in 2010, there were only 25 active glaciers left. Some of those are in danger of disappearing by 2030. Alaska's glaciers are experiencing the same fate. Since the Industrial Revolution, starting around 1760, human activity such as burning fossil fuels, industrial processes, agriculture, and changes in land use have increased the amount of carbon dioxide and methane released into the atmosphere. These gases have reached higher concentrations in the atmosphere than at any time in the last million years. Scientists know this from studying the bubbles that are trapped in glacial ice that show the composition of the atmosphere at the time the ice was formed. These gases are also largely the cause of climate warming and glacier retreat. During ice ages, carbon dioxide levels were around 200 parts per million, and during warmer interglacial periods, they were 280 parts per million. In 2013, they were over 400 parts per million, and in 2023, NOAA reported levels as high as 421 parts per million. Greenhouse gases absorb heat being radiated from Earth's surface, and by absorbing this heat, the atmosphere and oceans are slowly warming up. Warming ocean and air temperatures increase glacial ice melts. Thus, scientists have confirmed that glacial retreat is an unintended effect of the Industrial Revolution and modern energy use. Increasing temperatures are not the only cause of glacier ice melts. Increased dust and soot from grazing, farming, and burning of fossil fuels and forests also increase glacial retreat. Dust and soot settle on glaciers to form a dark layer that absorbs more solar energy and increases their melt. Alaska is warming 2 to 3 times faster than the global average. The melting snow and ice expose more dark land and water, which absorbs more solar energy, which causes more warming. One of the most serious consequences of global warming is the rising sea level. Global sea level has been rising since the early 1970s. Between 2000 and 2019, glacial mass worldwide dropped by 267 gigatons per year. Scientists estimate that the melting of glaciers contributed to roughly 21% of observed sea level rise. A high percentage of the world's population lives near the coast, and as the sea level rises, people are being displaced due to increased coastal flooding and erosion. With so much human activity concentrated along coastlines and areas only a few meters above sea level, even modest flooding has already caused societal and economic distress and has put coastal communities and infrastructure at risk. Here in Alaska, sea level rise has already been impacting our communities. Newtok, which is the community shown in the image on the left, is a village that has had to relocate. Shishmurnoff, which is shown on the right, is suffering because of the erosion and storms, but they have not yet been able to relocate due to the $180 million price tag to relocate their village. If coastal communities are able to remain, properties become more difficult to insure, and they are at continual risk of flooding as coastal storms become more frequent. The rising sea levels increase coastal erosion and elevate storm surge as the warming air and ocean temperatures create more frequent and intense coastal storms like hurricanes and typhoons. Typhoon Halong hit the western coast of Alaska on October 12, 2025, and affected nearly 50 communities. The Yukon-Kuskokwim Delta, which is the image on the left, was very heavily impacted by this typhoon. And the image on the right is the town of Kipnuk, and in that area, over 1,500 people had to be evacuated. People have had to make the decision of leaving their homes, and some of them believing they will never be able to return because their villages are gone. There are 18 villages on the outer coastal area of the Yukon-Kuskokwim Delta, and at least 10 of those villages will likely have to be relocated. Many people are currently displaced and housed hundreds of miles from their homes and unsure of what the future will hold for them. Humans are not the only ones impacted. Wildlife are also impacted. Walruses are losing their homes, and polar bears are spending more time on land, which is making human-polar bear interactions more common. Glaciers act as natural reservoirs, storing about 70% of the world's freshwater. Their melt is crucial for providing water during dry seasons, so melting glaciers threaten water security for people. There is ecological disruption due to melting glaciers. Melting glaciers release sediment and nutrient into waterways, altering aquatic habitats and affecting fish and wildlife. The colder meltwater also impacts downstream water temperatures, affecting where and when fish spawn and their food resources. The glacial melt in the Antarctic and Greenland is changing the circulation of the Atlantic Ocean and has been linked to a collapse of fisheries and more destructive storms. The loss of glacial meltwater affects agriculture and fisheries, potentially disrupting food supplies. There is also an economic impact to the melting glaciers. In Alaska, industries like tourism and fishing in glacier-dependent regions are negatively impacted when our glaciers disappear. Protecting glaciers requires us to prevent and lower warming as much as we can. Optimistic scientists believe that with immediate large-scale reductions in greenhouse gas emissions, we might be able to keep the planet from warming beyond the tipping point. The reduction in temperature would help us preserve glaciers and reduce other climate impacts such as severe weather events and sea level rise. However, accomplishing this is a very difficult goal because as humans, we continue to invest in fossil fuels and do not keep our emission pledges. Our individual actions may feel insignificant, but they are important because the world is made up of a lot of individuals. And when we work together, we can make a difference. As individuals, one of the most significant things we can do is to write our lawmakers and leaders in Congress asking them to support renewable energy, keep emission goals, and reduce the use of fossil fuels. We need to support sustainable policies. We can also refuse to support companies that are not working to limit their emissions and choose to support the ones that do. We need to hold companies and governments accountable to improving their energy efficiency and decreasing their carbon footprint. The glaciers of Alaska connect local life to global climate patterns, shaping ecosystems, sustaining communities, and reminding us that protecting them means protecting our shared future. Thank you all for joining me today.
All right, Laura, thank you so much. Now, Before we dive into the question and answer session, I would like to remind everyone that if you do have questions, you can submit them via the question field in your control panel. Just go to the upper right-hand corner of your control panel. You'll see those three lines there. Go ahead and click on those, and it'll open up all the fields. Go to questions, and that's where we will be asking them from. All right, so let's dive into these questions. So I guess here's one. Are there any glaciers in the world that are actually growing larger at this time?
There are reports that there are a few that are growing. It is very, very uncommon, and I don't have a specific one to tell you. A glacier forms when, snow doesn't melt away during the summer. So technically, you can have a glacier form over, say, like 5, 6, 10 years if you are on a colder pattern. But as soon as you get a warm spell, then that has changed. So I've read that there are a few glaciers that are growing, but not significantly at all, and not many. And some people get confused because you'll hear about a glacier that has surged or a glacier that has remained relatively stable, like at the face of it, like Ayalik Glacier has. But that doesn't mean that the glacier is not in retreat, even if it has remained stable at its face, because again, it can be narrowing at the edges, or it can also be thinning. It doesn't just have to be pulling back from the face. But the other thing with a surging glacier, you might have a glacier that had retreated 2 miles. For example, Muldrow Glacier in Denali a number of years ago surged. And that glacier, like it had receded and the face of it had gone further and further back, but then there was this massive surge where the glacier moved forward. But that didn't mean the glacier grew. It just meant that that glacier mass was pushed forward down to where the terminus of it once had been before, and that mass that had all been held further back up was now spread out over this area. And so it looked like the glacier had grown, but when you really took the measurements of how much ice mass was there, it was much less than it had been before.
Great, thank you so much. So how much has the average temperature increased in Alaska, and does the increase vary between South and North Alaska?
It does. I don't remember the exact number for the average for Alaska, but in the Arctic, it has the average temperature is changing about 4 times faster than it is globally. And so further south in Alaska, temperatures are not increasingly as rapidly as they are in northern Alaska. But Alaska as a whole, the average across the entire state is 2 to 3 times faster warming than the global averages are. And off the top of my head, I'm blanking what that exact number is for the average for Alaska that we're warming, but it's been significant. And pretty much every year we hit a new record of the number of days above freezing or the highest temperatures. I was just the other week listening to something that was saying our growing season has changed like 20 days where I'm at over the last like 30 or 40 years. So our growing seasons are getting longer. Our temperatures as a whole are significantly warming.
Okay, thank you for addressing that. So you showed a picture of the Bear Lake Glacier. It seemed to have lines on them. Were those vehicle trails? Can vehicles drive on that glacier?
They're not. Let me go back to that image. Sorry, we'll get back here. Where are you? They're called moraines, and sorry, I'm trying to find this so we can talk about it easier. But a moraine is where it's like edge of the glacier, you have a medial moraine, which is the middle, a terminal moraine, which is the front, or your lateral moraines at the side. Here we go. But what these lines are is this here is, you can see you have one glacier coming from this side, you have another glacier coming from mountains up in this side, and as those glaciers are meeting and forming, it's picking up the gravel with it, and that glacier is kind of acting like a bulldozer and pushing the gravel together as those glaciers meet up, and so it creates this medial moraine. So it does look like a road from the air, but it is not, and nobody can drive on them. And if you look at it like closely, it's actually really uneven, and there's like cracks in the ice and everything, but it's the gravel that's sitting on top of the ice that's been carved out by the moving glacier.
Gotcha. Thank you for addressing that. We were wondering what that was about, so good to know. So could you talk about why you see some glaciers and they seem to have a blue color to them?
So if we go back to that image I showed you earlier on about how much air is in the snow and ice particles, the more compressed air, or like the lower down in the glacier that the ice is, there's less and less air in that. And where there's less air, you're going to have the light rays go into those air pockets and into the ice, you're going to be having most of your colors absorbed and your blue reflected back to you. So when it's the snow and ice is higher up on the glacier, it doesn't look as blue as it does lower down because there's more air. And so you have more colors being reflected back to us than as you have more and more compression of that ice and just mostly the blue being bounced back to our eyes.
Gotcha. Thank you. Are polar bears and walrus and other life in Alaska, are they showing any signs of adaptations that may help prevent them from extinction or prevent them from being affected by the climate change?
From what I have found, they're not showing adaptations that are helping them fight the effects of climate change. Now, polar bears, they are seeing, I don't know if you'd call this an adaptation necessarily, but they are seeing them on land more, and they're seeing them, scavenge on land and look for food on land more than they have in the past. And so maybe over time that will be something that helps them sustain themselves, but then it also is putting them at more human interaction risk. And so they're definitely seeing changes in some of their behaviors, but whether that's an adaptation that's helping them survive, at this point it doesn't seem like it, because their numbers are still continuing to decline significantly. And you would think that if it was an adaptation that was helping them survive, you wouldn't see the same decline in their numbers as we've been seeing.
I see. Thank you. So what are some ways that we as regular people can help with the climate change and with cutting down our carbon emissions, besides, perhaps maybe not driving our car as much? Is there anything on a regular basis that we can do?
I mean, I think there's a number of ways to look at it. Like, we can reduce our individual footprints the best that we can by reducing our use of plastics, by reducing our use of, fossil fuels, by reusing things, by consuming less, by replacing our electronics less, by, there are things that as individuals we can do. And sometimes people feel like that doesn't make much of a difference, because what difference does it make if me as one person replaces my phone every year, every 5 years, like really what difference is that going to make? But if we're all making these kind of choices, or many of us are, that can contribute and make a difference. But a lot of times what's encouraged is that we are not just using our decisions, but also our voices of saying, you know what, we are going to not use this company because they are making decisions that are not environmentally friendly, or we are going to support this company. It might be a smaller company, but we're going to invest and put our money there and support that company because they are making good environmental decisions. And then even bigger than that is us going and, you know, holding our, like writing letters to congressmen and our lawmakers and saying, this is what we stand for, this is what we want as people. And so making our voices heard is a way that we can be a part of trying to change that. And it can feel really daunting because you look at this whole scale and you're like, I am one person, but we're all one person. And if each of us are making decisions for the environment, then we can see major changes. And, you know, like with traveling with NatHab, like we do carbon offset for our office emissions and our flights, and we're working at other ways to reduce our carbon emissions. And you know, like we've worked at getting plastic water bottles off of all our trips and things like that. And so over time, decisions like that really do start to make a difference. But I would really say, like looking, like for me personally, one thing that it has been is like, look at my consuming. How am I consuming? What am I consuming? And start there, and then try to let that build outwards to other aspects of my life and going further and influencing other people, starting with the people around me and then working my way towards what businesses I'm willing to support, and like working, trying to make differences, of encouraging our lawmakers to make wise choices as well.
Great. Thank you for that advice. So let me ask you this. Now, if I'm coming out to Alaska on the ultimate Alaska trip, which glaciers will I be able to see?
Most likely you will have an opportunity to see the Ruth Glacier in Denali National Park, and if not that one specifically, other ones that are up in the Alaska range, just depending on flight routes. You will most likely see Bear Glacier, Holgate Glacier, and Ayalik Glacier down in Kenai Fjords National Park. And then sometimes as you're driving, you'll see a couple different glaciers from the road in the Alaska range as well. And then depending on if you're going out to Bear Camp or out to Katmai will change, but there's often some glaciers you get to see as you're flying to those destinations as well, but the flight paths really vary for those, so it's a little bit harder to say. But usually the ones in Kenai Fjords, with Bear Glacier, Ayalik, and Holgate Glacier are your main ones that you'll get to see.
Gotcha. Thank you for that. Well, unfortunately, that is going to be the last question that we do have time for today. So I'd like to throw it back to you for any closing comments you may have for us.
Just want to say thank you all for joining me, and let's work together to protect our glaciers. And if you haven't had a chance to come see them, come on up and visit and take a look at them because they're pretty amazing.
Great, Laura. Thank you so much for this wonderful presentation. A lot of people are really happy that you gave it for us today. So thank you for letting us know about some of these things and this amazing trip as well. And I'd like to thank everybody else who joined us today. So if you are interested in information on how you can travel with NatHab up to Alaska, please give us a call at 800-543-8917, or you could just send us an email at info@nathab.com. Our adventure specialists are happy to help you out. Join us tomorrow for our next Daily Dose of Nature. You can check out this week's lineup, including registration links, on our website at nathab.com. timecodescom/webinars. We did record today's presentation, and we will have the replay available on our website soon. With that, I will conclude today's webinar. So long, everybody. We will see you next time.